Hello everyone, I hope my audio is good. Thank you for joining this webinar. My name is Joe Hoyle. I've worked at Mavens for 3.5 years. My specialisms are website performance optimization and website governance. I've worked with many brands to provide insight into the performance of their digital presence and have helped them to make their websites faster. In this webinar, we will cover why you should care about site speed, the current state of web performance, the business case for optimization. We'll look at the barriers faced by businesses in resolving site speed issues, and we'll cover how to improve site speed and how we can help. So, why should you care about site speed? You should care about site speed because users care. It's not enough that your site might look good, be easy to use and secure. Users are very impatient. They'll bounce if they have to wait too long for a page to load. A lot of research exists to support this. Akamai, who run one of the world's largest content delivery networks, revealed that 1 out of 2 people expect a web page to load in less than 2 seconds. Google discovered that 46% of consumers say that waiting for pages to load is what they dislike most about browsing the mobile web. And Google research also revealed that 89% of people are likely to recommend a brand after a positive experience on mobile. The second reason is that site speed influences search ranking, the user experience, and your bottom line. Speed is good, it's the forgotten conversion factor, and it creates competitive advantage. In a mobile-first world, the lower bandwidth, smaller memories, and lower processing power of mobile devices have made front-end performance optimization a business-critical endeavor, but it doesn't figure in the mindset of most site owners. I would argue that site speed is the most important UX feature of your site. If users bounce because the site is slow, all other efforts to improve SEO, content, and functionality effectively drop in value, or dare I say, become worthless. Research by Google revealed that 53% of visits are abandoned if a mobile site takes longer than 3 seconds to load. Akamai discovered that optimal load times for peak conversions were 1.8 seconds for desktop and 2.7 seconds for mobile. The same report by Akamai also revealed that just a 100 millisecond delay in load time can hurt conversions on mobile by up to 7%. For desktop, the reduction in conversions was found to be 2.4%. The third reason is because websites contribute to global warming through energy consumption and thereby carbon emissions. According to the Sustainable Web Manifesto, if the internet were a country, it would be the 6th largest polluter in the world. The internet draws a lot of power, which in many countries is generated by burning fossil fuel. It's been described disparagingly as the largest coal-fired machine on Earth. The ITU estimated that at the end of 2019, nearly 54% of the global population, or 4.1 billion people, were using the internet. According to some estimates, the carbon footprint of our gadgets, the internet, and the systems supporting them account for about 3.7% of global greenhouse emissions. This is similar to the amount produced by the airline industry, and these emissions are predicted to double by 2025. And according to the website Carbon Calculator, the average website produces 1.76 grams of CO2 per page view. Slower websites are likely to generate more carbon emissions, and I'll come back to this point later in the webinar. So, if site speed is so important, how are websites doing? Well, sadly, websites are getting slower. These graphs from the Nielsen-Norman Group show that the average internet connection speed for users in the US has steadily increased, but load times for desktop and mobile have not improved. For the past 10 years, HTTP Archive has recorded page load times for millions of popular websites. The results are quite shocking. For web pages visited from a desktop computer, the median load time has not improved. Today's websites aren't that much faster on desktop than they were 10 years ago. And the load times for mobile web pages over the same period have more than doubled. Google recommends that pages load within 5 seconds on a mid-range smartphone using a fast 3G connection. HTTP archive data reveals that the median load time of homepages from a sample of more than 5 million websites currently stands at 19.6 seconds. This chart from HTTP archive shows the distribution of load times from the 25th percentile to the 75th percentile. So that's on the good end of the user experience to the poor end. The blue shaded area is for desktop percentiles, and the purple is for mobile. The 25th percentile of load time for mobile was 12.4 seconds, and the 75th was 30.9 seconds in March this year, nowhere near Google's recommended target. That is a lot of business that's being lost due to poor site speed. Google adds that you don't have to load everything in under 5 seconds to produce the perception of a complete load. As a minimum, a page should be visually complete above the fold and interactive. That means responsive to user input within 5 seconds for a first visit. So, if hitting visually complete and time to interactive in 5 seconds is a more realistic target, how a website's doing? Well, every year, the Web Almanac publishes a State of the Web report based on data from the HTTP archive. Looking at the raw data reveals that in the middle of 2019, when the data was gathered, the median time for a page becoming responsive to user input was 10.8 seconds, and visually complete above the fold was 16.2 seconds, still well short of the 5-second target. Although network and phone technologies advance year on year, the time it takes to load a page is taking longer. The site owners add more weight and complexity. The delivery of heavy, complex pages over congested mobile networks with low bandwidth and high latency is creating a perfect storm of poor user experience. In March 2015, the median homepage weight sent to mobile devices recorded by HTTP archive was 818 KB. In March 2020, it's at almost 2 megabytes. That's an increase of 130.4% in 5 years. A breakdown reveals 137% increase in image weight, 55% increase in font weight, 110% increase in JavaScript weight. JavaScript is the web's programming language. And 134% increase in CSS weight. CSS is the web's styling language. If that is all a little depressing, there is actually some good news. Major internet companies are becoming more energy conscious and choosing renewable sources of power for data centers and transmission networks. Despite the exponential demands placed on data centers and transmission networks, government policies and improvements in energy efficiency have helped to limit the growth in demand for electricity. Global internet traffic has tripled since 2015 and is expected to double by 2022. Mobile users are expected to reach 5 billion by 2025. But based on current trends in the efficiency of hardware and data center infrastructure, global data center energy demand is projected to decrease slightly in 2021. However, there is a caveat. If efficiencies do not continue, we could see data center usage grow within a range of 3 to 13% of global electricity by 2030. Estimates put it at 2 to 2.5% of global electricity at present. Before I discuss how to improve site speed, I want to take a deeper dive into the business case for optimization. If websites are getting slower and contributing to climate change, the answer is simple. Optimize for performance and the rest will fall into place. Google uses mobile-first indexing and has acknowledged that site speed is a ranking factor. In May this year, Google introduced a new set of performance metrics called Core Web Vitals, and these will be used next year as part of search ranking signals. I'll talk about these a bit more later. Optimize for speed and you will most likely improve your Google ranking. You'll also improve the customer experience, brand perception, and metrics like bounce rate, page views per visit, and conversion rate. With optimization, you'll reduce data storage, server-side processing, client-side processing, network congestion, energy consumption, and CO2 emissions. In short, optimize for speed and you'll generate happy customers, a happy business, and a happy planet. Fashion retailer Misguided removed Bizarre Voice for Android visitors, and median page load time improved by 4 seconds and revenue increased by 26%. Bizarre Voice is a digital marketing company based in Austin, Texas, and it provides software that allows retailers to add custom reviews to their websites. AliExpress reduced page load time by 36%, recording a 10.5% increase in orders and a 27% increase in conversion rates for new customers. And Trainline reduced load time by 1/3 of a second across their funnel, and revenue increased by an extra £8 million a year. Oh, sorry, I didn't forward those slides. I'll leave that on screen for a few moments. At Mavens, we've worked with a lot of clients to help improve site speed, and we see the same pattern again and again. Optimize for performance and good things happen. We worked with a global food and beverage brand, which launched a new website only to find that its speed was terrible. Within a week of implementing our site speed recommendations, the client saw a 63.5% increase in users, a 61.5% increase in visits, and a 53.6% increase in page views. And we calculated that the improvement in site speed was worth almost $500,000 in the first year. I like this slide a lot. It exemplifies very well the relationship between site speed and user engagement, and shows the page load time distribution compared with bounce rate for a client site that we analyzed. You can see that bounce rate rises steeply as pages take longer to load. Pages that load the fastest have the lowest bounce rate of 22%. This rises steeply as load time increases. Then bounce rate begins to flatten at around 7-8 seconds, where bounce rate is 74%. Now, what's interesting about this particular bounce profile is the obvious performance poverty line at around 7 seconds. The poverty line indicates that for this particular site, optimizations most likely won't have a significant impact until users experience page loads lower than 7 seconds. So despite clearly defined performance targets recommended by Google, the poverty line insight gives site owners a clear first milestone performance target to aim for. In May this year, Google introduced a new set of performance metrics called Core Web Vitals, which include the measures first input delay, largest contentful paint, and cumulative layout shift. In 2021, these will become ranking signals. Largest contentful paint marks the point in the page load timeline when the page's main content is most likely loaded. First input delay measures the time from when a user first interacts with the page to the time when the browser is actually able to respond to that interaction. And cumulative layout shift measures the total of all individual layout shifts during page load. It can be very frustrating for users if they have to wait for a lot of page elements to stop moving around before the page is fully rendered. Over the next 6 months, improving site speed should be a priority for any site owner with less than good performance. Google has explained that a page passes Core Web Vitals assessment if the 75th percentiles of all 3 metrics are defined as good. So the poorer end of your user experience has got to be good. Otherwise, the page does not pass the assessment. It uses anonymized data from millions of people who use its Chrome browser to check site performance against the new metrics. And my initial investigation of about 100 top brands across 10 industry verticals reveals that site owners have a lot of work to do to pass Core Web Vitals. I just want to take a closer look at the cherry on the cake, the reduction in carbon emissions that comes with performance optimization. The slower the website, the greater its energy consumption. I'll explain how this works. Heavier websites require more data storage, One of the major causes of bloat on the web is poorly optimized images. These use up space unnecessarily. Of all optimizations, reducing image weight is probably the easiest to achieve. It is a really quick win. Another major issue is the rise in the use and weight of JavaScript. More code and complexity generates more processing server-side. Poorly optimized websites transmit more over the network than is actually necessary. More code and more complexity means that browsers and therefore processors have to work harder at rendering a page. This uses more energy client-side and drains mobile battery power. Overall, more energy is consumed than is necessary, which in turn contributes to more CO2 emissions if energy sources are not renewable. Using the formula developed by Whole Grain Digital for use with their website carbon calculator, we estimate that the reduction in energy use and carbon emissions set out here could be made in a single year simply by reducing homepage weight alone by a modest 10%. We looked at the median weight of homepages in the HTTP archive dataset, the 25th percentile of weight, and the 75th percentile. For the 25th percentile with a weight of 908 KB, a 10% reduction in homepage weight would result in enough of an energy saving to make 925 cups of tea or drive an electric car 92 kilometers, a reduction in CO2 of 6.8 kilograms. For the 75th percentile with a weight of 3.6 megabytes, the energy saving would be enough to make 3,732 cups of tea or drive an electric car 371 kilometers. That's a reduction in CO2 of 27.6 kilograms. Our calculation is based on a website that does not use a hosting service with a renewable energy source and has 10,000 monthly homepage views on mobile. So if the business case is so strong, why isn't everyone optimizing for speed? In our experience, many businesses face significant challenges when it comes to performance optimization. The first challenge is awareness. A lot of businesses don't know if their speed is good or bad. They don't know how fast their site is and don't know how fast it should be. A lot of businesses aren't even aware that speed is important. The second barrier is insight. Businesses tend to have no understanding of the relationship between speed, user engagement, brand perception, and conversion, and have no idea how site speed is impacting their bottom line. Complexity is another problem. The things that cause poor site speed can lie anywhere in millions of lines of front-end code, in the speed of your back-end infrastructure or your CDN, your content delivery network. Identifying problems and knowing what solution to put in place are significant challenges. And even when you've found a problem, you then have to identify the team responsible for fixing it. And when faced with multiple issues, how do you prioritize which issues to fix first? This is where Mavens can help. We have significant experience of improving performance for a wide variety of clients. Our recommended strategy is comprised of 4 pillars. We have a clearly defined process and methodology for improving site speed that is proven to work. In this final section of the webinar, I'll cover the activities that we recommend within each pillar. The first step in optimizing for speed is to gather performance data using synthetic analysis and real user monitoring. Synthetic analysis basically involves testing pages under controlled conditions, where you select the device type, connection speed like 3G or 4G, and device processing capability like mid-range smartphone, using tools like Web Page Test, Speed Curve, Lighthouse, and GTmetrix. Some of the questions synthetic measurement can help answer include: how much does a page weigh? How many server requests does it make? How do you stack up against competitor sites? How does the design of your pages impact performance? Synthetic tests are periodic, they're not ongoing. Analysis is limited by the number of control conditions available to the testers. RUM, or real user monitoring, is the appropriate solution for determining the experience of real users and the speed of pages in the wild. It can be ongoing. In other words, continuous measurement of every visit. To gather RUM data, or field data as it's also known, you need to add code to your pages, and this returns speed data to a RUM platform. Some of the questions RUM can help answer include: how fast are my pages for real users? What types of device do they use? Which are the best and worst performing pages? What is the correlation between performance and bounce rate, engagement, and conversion? RUM analysis is unlikely to help you understand why pages perform well or poorly. For that, you need to use synthetic analysis. Companies that provide RUM platforms include New Relic, Pingdom, Impulse, and SpeedCurve. Google Analytics and Adobe Analytics also collect and report on RUM data. We recommend reporting on a set of mainly user-centric measures. These provide insight into a user's perception of how fast a page renders content above the fold. They include, for example, first contentful paint, largest contentful paint, visually complete, speed index, time to interactive, among others. A good place to start is with Google's Core Web Vitals. Google has done all the hard work for you by researching and defining the measurements that provide great insight into the user experience. Core Web Vitals and many more measurements can be gathered by a variety of synthetic and RUM tools, and these can help you identify where bottlenecks lie in the page load process. For example, is your server slow? Or does the browser take ages to process your front-end code? Synthetic analyzers will tell you where problems lie, or will at least give you a clue, but at some point you're going to have to get under the hood and analyze the code. Performance analyzers can tell you if you need to optimize images, for example, or delay the delivery of some JavaScript, but they won't tell you everything. And we've found some very odd reasons for poor site speed by digging into the code. In our site speed audits, we benchmark various elements of a page, such as page weight, server requests, images, CSS, JavaScript, and what's called DOM complexity, against performance size to give context to the build condition of a site. DOM isn't a friend of mine, it stands for Document Object Model. DOM complexity refers to how complex the structure of the HTML document is for the browser to understand. Out of all this work, we identify what optimizations need to be made. And from this, we create a prioritized set of actions for client developers to follow based on the impact of each optimization and the effort required to implement it. If you don't use a green host, we recommend that you consider switching to one. First, you need to check if your current host has green credentials. You can do this very easily by using a free online service like thegreenwebfoundation.org or the website Carbon Calculator. You just enter your URL to find out if you are already using a green host. If not, you can use the Green Web Foundation directory to help you find one. The next steps are all very obvious, but should be taken with careful planning in conjunction with your technology supplier. Once you've found a green host, you'll need to migrate your code and content from your old to new host. Back up everything before you go live. Change your DNS settings. And once you're happy that everything is running as it should, decommission your old environment. There's little point in optimizing for site speed if you don't also set targets and constantly monitor performance. If you don't do this, you'll most likely suffer speed regressions within a very short time. We recommend that you benchmark your site and establish a performance budget. It's important to understand how your site performs in specific conditions using synthetic testing and in the wild with real users. A performance budget is a limit for pages which you set and should not exceed. Metrics for perf budgets can include things called milestone timings, like be interactive within 5 seconds on FastG. Quantity-based metrics, such as a maximum JavaScript bundle size, so collection of JavaScript files, or total image weight. It can also include rule-based metrics, like scores generated from Google's Lighthouse 2. Google spent a lot of time developing its Lighthouse synthetic analyzer and its speed scoring model, which combines measurement of a variety of user-centric measures into a single performance score. And this helps to simplify performance scoring for the non-technical. Google's score ranges from 0 to 100. A site isn't considered fast unless it scores 90 plus, which for the majority of feature-rich sites is very difficult to achieve. And I think a more realistic target might be somewhere around 80 to 85 for a feature-rich site. It's important to monitor performance in the wild. This requires RUM, real user monitoring, normally done through a platform like New Relic, Impulse, or some other RUM platform. It's very unlikely you'll ever get access to competitor RUM data from their RUM platform, but data from Chrome users is available in Google's Crux dataset, and this could be queried using SQL so that you can benchmark yourself against competitor sites. Crux contains anonymous data gathered from millions of people using Google's Chrome browser. As a minimum, aim to be 20% faster than your competitors, according to the Weber-Fechner law and principle of just noticeable difference. This is the amount something must be changed in order for a difference to be noticeable by humans. Use synthetic testing to audit the performance of updates and enhancements prior to release, and monitor synthetically the speed of key pages in production. As part of the web development lifecycle, we recommend that you conduct synthetic application performance testing and analysis in a UAT or development environment prior to the deployment of any updates or enhancements in production. The impact of updates and enhancements on site speed should inform decisions on whether to release to production. This strategy is critical to the prevention of performance regressions. The final pillar in our recommended strategy involves developing a performance culture. Creating a successful performance culture means creating a feedback loop in your business that looks something like this. You have to get people to care about site speed, involve them in making things better, and then ensure that you celebrate and share success. SpeedCurve cover this in some depth in one of their blog posts. To get people interested in site speed, find out which metrics motivate them. It might be bounce rate, time on site, revenue, whatever it is. Once you know what excites them, show them how site speed can help. It's probably easiest to do this with case studies. There are case studies which demonstrate the relationship between site speed and all manner of metrics. A good place to start is with wpostats.com, and this has recently been updated with some 2020 case studies. Tap into the competitive spirit of your colleagues. Use web page test Lighthouse or page speed insights to show how your site compares with that of competitors. Once you've set up performance reporting, make it as visible as possible. If you have the resources, create different dashboards to include the most important KPIs for different stakeholder groups. Involve key stakeholders in the process of setting performance budgets. You'll get much better buy-in if people are involved in the process. And every time you move the performance needle, shout about it, celebrate, and share success with colleagues. A study called Field Experiments of Success Breeds Success Dynamics found, surprise, surprise, that success does actually breed success. I'm going to wrap up now and list key takeaways. First, time is money, but poor site speed not only affects your bottom line, it contributes to climate change. Measure performance to identify how fast your site is against recommended targets and the competition. Audit performance of your site to identify performance bottlenecks and where you can make optimizations. Prioritize your effort and take ameliorative action to optimize performance. Put optimizations in your development backlog. Migrate to a green host if you don't already use one. Set the performance budget and monitor site speed in the wild. Bring synthetic performance analysis into your development lifecycle to prevent performance regressions. And develop a performance culture in which everyone cares about site speed. If you'd like to get in touch to discuss site speed, these are my contact details. So next we can move on to questions.
Super, thanks, Joe. Yeah, so we've had a few questions in. As I said earlier, if we don't get to yours, then we will come back to you individually. The first one, a couple of people have asked actually, if you were to select one metric to focus on, what would it be?
I think it would be different depending on whether you are doing synthetic analysis or looking at RUM data. So for synthetic testing, so lab testing under controlled conditions, I would use a lighthouse score because it provides a composite score based on a number of key user metrics. And Google's done all the hard work in working out the scoring calculation for that. It's a nice high level score that you can apply to site speed. And for analyzing performance in the wild, so real user monitoring, I would use Core Web Vitals and determine whether not what's called an origin, a whole domain, or individual pages pass or fail Core Web Vitals. By aiming to pass, you not only improve site speed, but you are also likely to improve SEO because Google will be using Core Web Vitals in its ranking signals in 2021.
Okay. Super, thank you. The next one is, won't 5G solve site speed problems?
5G will be fast and it will improve network latency. But some experts argue that it might make things worse, not better, at least in the short term. I think the major problem at the moment, as I've outlined in one of the slides, is the amount and the complexity of the code we're sending over the network. You saw from the Nielsen research that though connection speeds have improved over time, load time for desktop stayed about the same, and for mobile, it's got worse. With every jump in connection speed improvements, we tend to see a rise in the amount and complexity of code sent over the network. This takes a long time for low and mid-range smartphones to process, and even top-end phones struggle. The issue will be the ability of phones to deal with all the stuff that we send over the network, and once 5G hits big time, we're likely to send a lot more stuff over the network.
Okay, super. The next question is, how important is content compared with site speed in Google's search algorithm?
Problem with Google is it never provides a lot of detail about its ranking signals, but it has said a good page experience doesn't override having great relevant content. However, in cases where there are multiple pages that have similar content, page experience becomes much more important for visibility and search.
Okay. And another one here. So what have you found to be the biggest barrier to improving site speed?
Sifting through millions and millions of lines of code. No, I think that biggest barrier is awareness. awareness across everyone involved in developing a site, from brand managers to developers. There's a lack of awareness in how much money brands are hemorrhaging due to poor site speed. Many brands spend a lot of money on digital advertising, and a significant number of users click on ads, which cost money, and then they bounce due to poor site speed. I think that once a team understands the importance of site speed, and you start working with them to improve it, they get hooked on improving, monitoring, and avoiding regressions, because they can easily measure and they can easily see the benefits.
Okay, super. Well, thank you again, Joe, and thank you everyone for attending. If anyone does have any further questions off the back of today, then please do feel free to reach out to us, and let us know also if you would like to receive a copy of the recording or the slides. Okay, great. Thank you very much.
Thank you.